If you're building an AI right now, speed and reliability matter more than anything. And that's why I think Rust deserves a spot in your toolkit, even though it can be a bit intimidating at first glance. Welcome to AI Startup Labs. I'm going to be leading you through creating a chatbot with Rust. We're going to be building the chatbot in 3 parts. We'll start off with some simple prompting, then we'll wire it up to Tauri, a cross-platform application framework. We'll wire it up to a mobile user interface. And later on, we'll add in some MCP server tool calls. When I first got into using AI agent frameworks in Python, the first thing I noticed was it's a bit slow. Since I've been using Rust, I knew it didn't have to be like that. The ecosystem is growing. There are some great new libraries out there to help you orchestrate agentic workflows. We're going to be exploring this library, Rig, today, which is going to help you build apps like this quite quickly. This is aimed at a technical audience. If you're from another language, you can follow along. I'll do a bit of hand waving here and there in parts of the language that I don't want to go too deep into right now. And we'll go through the hiccups together so you can see some of the gotchas that might stop you if you try and do this yourself. The code is available on GitHub, and you can find the link in the description below if you want to follow along. In today's video, we're going to start off with a simple prompt. We're going to set up a tool, a very basic one that tells us the time. Think of it as like your starter brain for your AI app. Okay, so let's get started. Best place to do that is obviously on the Rig website. We'll go over there, we'll have a look. Why Rig? Well, it's a good question. Full support for LLM completion and embedding workflows. We're not going to do any embedding workflows right now, but we're going to try that a bit later on. We already talked a little bit about why Rust might be a good choice for this. It's not as popular right now, but the ecosystem is growing, and Rig's a great example of a library that will help you to make an app pretty quickly. So we'll go straight ahead with a quick start guide, make sure that we have everything we need. First of all, we're going to go to our IDE. We're going to start a new project. So here we have our fresh Rust project. We're just going to follow the instructions, add our dependencies. And while that's going on, let's go back and see what else it has for us in the tutorial. So basic usage. So it's pretty straightforward. If you haven't done Rust before, this stuff basically you can ignore for now. Just think of this as your entry point for an asynchronous application. We're going to be making an API call, so obviously that's going to be async. All we have to do is set up an OpenAI client and then set which model we want to use using the agent method here. And then we're going to prompt it. So it's pretty straightforward. Obviously println is just going to log this out to the console. We're going to do something a bit more advanced with that later on, but for now, let's see if we can build with this. I have to note that the Rig API is still evolving. So we have our fresh project here. We're just going to follow the instructions, see where we get. I wanted to do this pretty much live so that we could go through the hiccups together, try and demystify this whole thing about Rust being difficult to learn. Well, it doesn't have to be. So, of course, immediately compiler errors. This is a great example of when knowing tricks of the trade definitely helps. So we have Tokyo here, but we have a version, we don't have any features. So usually the way you would add it is you would add it with features full just to start off. But if you want to limit the features, feature flags are a great way of doing that in Rust. And you can see that's fixed that problem. So that was the first thing. Now, what else have we got? From end. This is a great example of a Rust pattern which helps you mix in behaviors. It's called an extension trait, and it says it's implemented but not in scope. So use Rig client provider client. So we're just going to copy that. And we're going to have the same kind of issue here. So client completion. Auto imports don't actually, at least on my setup, auto import the extension traits. So this is kind of a little gotcha that you might encounter working with Rust, but if you follow the very helpful compiler errors, it usually works out pretty good. We're just going to do a nested import here. Client completion dynamic. Okay. That's great. All of our red squigglies are gone. We're good to go. We can probably just run this, actually. Let's try it. Cargo run. See what happens. Obviously, it's going to compile. You also get used to that with Rust. In the meantime, let's go and have a look back at the README. You need an open API key. I'm not just going to search GitHub for that. I actually have my own one. This might be why it's panicking, actually, as well. Yeah, open API panic. So it won't let you continue. It won't even let you compile and run without this. So we set our open API key. I did it without showing you. I'm obviously not as generous as everyone who's checking it in. Let's see if we can run it. Hopefully this time it compiles. And it does. Great. It worked. So now what? Let's go back to the README and see what else we can do. Tool function with Rick. So what do we need a tool for? Well, if we want to make agentic workflows, it's not just good enough to chat with GPT-4. We need to ask it to do something. And to do that, we need to create a tool. Let's keep it simple for now. We're just going to ask it to give us the time. For that, we're going to need some dependencies. We're going to need chrono, Serde, which is a serialization and deserialization library. And we need the JSON version of that so that we can easily pass into JSON. We're going to use some rig core interfaces here. So we are going to bring in tool. I love tool. Yeah. We are going to bring in completion tool definition. So that's going to help us to define our tool. It's actually not finding that because actually when you import, you've got to use rig rather than rig core. Now we need to create some arguments as we saw in the documentation. Just going to paste this in here. It's pretty simple. It's an empty struct because we don't need to pass it any arguments. Then we need to define a struct for the actual tool. You might notice here we've got a couple of traits. The tool interface is going to require these, so we're just putting them up there in front, but basically means you can serialize or deserialize it, and that's coming from Serd. This one has clone, so just meaning it's copyable. This is the name of our struct, which is going to be the name of our tool. And now it's Copilot's asking to complete the whole thing for me. But we don't always trust Copilot, so we're going to just start with implementing tool for our struct here. So get current time. And we know it needs a name. So actually autocomplete can do this. It's not Copilot. And we can trust autocomplete because of the static code analysis based upon the types given to us by the library. So that'll be fine. So now we also need a type arg. It's listed here in my autocomplete. So we need to, yes, use the args that we already defined. We also need to define an error type. We're just going to use the error from Serd.json here. So I'll just put error, and then I'm going to import from Serd.json. And then we will have the output type. And that's going to be also from Serd.json because we love the JSON. And we will import that so that our output type can be JSONifiable, if that's a word. Okay, definition. This is something we're going to need, but that's not really how it's defined. You got to be careful with Copilot. But this is the good thing about Rust is it kind of has its own Copilot. So we have definition here, and that's going to fill out the actual type signature of our method here. We're going to just paste in some basic tool definition for now so that we have something there. This is a long way of saying it's a future. It's asynchronous, but basically it's just returning a tool definition. You can ignore the other stuff for now. It can take a prompt, which is a string, and we're just going to return a tool definition. That was imported, so obviously if you want to find out what that is, you can look here, you can look in the docs, but it's a name, description, and some parameters. You can copy that from the documentation. We also have a call method, which is the other part of this interface, and we are going to copy in the definition that we wrote earlier on, which is pretty straightforward. We just want to get the time, so we need to have local time. That's what we had chrono for. It's returning a date time, which has its own format method on here. We're just going to format it in a nice way, turn it into a string, and then we're going to use JSON. This is a declarative macro, which is basically going to help us just format that into JSON with our formatted time and with a field current time. We're missing something here. It's still complaining at us. Trait future is not implemented for tool definition. Tool definition is not a future. So what do we do? Well, we add async, because even though we did use the static code analysis to do this, if we change that away from being a future and actually just return tool definition, and we just return self.output, or a result of self.output, it'll imply that it's a future based upon the async label. So now it's not complaining as much. It's missing a trait bound. Deserialize is not in scope, so I need to just bring these in from Saturday. And now it's saying this isn't used. We won't worry about compiler warnings right now. We got rid of the errors, so it's a good start. So we have our tool, which is going to just give us some JSON telling us the time. Not that exciting, but we can wire it up to our agent, which is just going to be an LLM that's given a tool to do something. Okay, so let's go back to the documentation. What do they do with their tool? You can call it with your agent during the builder method. So instead of just prompting it, we can give it a preamble, which is going to tell us how to use the tool. Calculator, URL calculator. It seems a bit reductive. It's an LLM worth billions of dollars probably. We're using it as a calculator, but the thing you'll learn about tools and agentic workflows is that you want very specified, clearly defined roles, and that way there's less margin for error, less room for hallucination. We're using GPT-4 here, but we're actually calling this in a different way, because once we have our client, which we already made, we're going to use this agent method on the client. We're going to feed it the model name, but not as a string. We're going to use this enum here. There's a lot of different providers you can use with Rig. We're going to stick with GPT-4. And then we're going to give it the preamble, telling it what its role is, what to do, use the tools provided to answer the user's question. Max number of tokens that we can use for this, and we feed it the tool. And then we use the great builder pattern to give us our agent. Let's move over and do that with our agent. Now, in order to move away from simple prompting to an agentic workflow where we ask for the time, we're going to use a new asynchronous function. We're not going to do it all in the main function. And this is going to really help us when we come to link it up with Tauri later on. So we're going to create async fn, and we're going to call it chat with agent. We're going to give it a message, and we're going to leave it at that for now. We're going to return a result of a string or void for now. I'm just going to start by returning a result. We're going to get that result. First of all, we need to create an OpenAI client. Well, we already have one of these down here. So we're just going to move it up. We need to ask that client something. We need to ask it to use a tool. So let's do that up here as well. Now we're going to need to import the tool. I think this part of the API has changed, as we saw in the documentation. So we're just going to copy that over. Providers, OpenAI, GPT-4. We can use O, just to keep it consistent. We have to import that, obviously. We are helpful assistant. Use your tools when necessary. That works. but we're not returning a string yet. That's why it's complaining. So we actually need to prompt the agent. So we're going to make a match on the result of prompting this agent. So our result will be, well, this is where Copilot is useful because it knows that a match on this kind is always going to be an OK or an error. So we'll let it take that for now so that we get either a string or we get an error. We're not going to do any error handling right now. That's kind of out of scope of what we're doing. So we have this function compiling, which is pretty great, but this is complaining. So this is because this is the old code. So we want to get a response now by chatting with our agent. We need to pass it a message. So let's call chat with agent over here. This time, Copilot pretty useful. Chat with agent, what is the current time? And we're just going to not handle the error. That's what this means. And wrap or else, it's going to give us a string, and we're going to log that out. And we're compiling again. So let's try and run. Ooh, exciting. Going to take ages to compile again. It's going to complain about something, and then it's going to tell us the time. It worked. It used the tool that we created in the other file to tell us what the time is. Is it accurate? Yes, it is. It's basically dinner time. I'm going to go ahead and eat my dinner, and we'll come back later on to make this into a mobile app. Today, we used Rig, an LLM framework for Rust, to create a simple AI application that tells us the time in the command line. Next time, we'll scaffold a Tauri app and actually wire up our agent to a UI running on an Android device. If that sounds good to you, hit subscribe so you don't miss it, and I'll see you in the next video. And let me know in the comments, what kind of AI agent would you like to build?